Our solar system is a treasure trove of celestial wonders. Among them is 16 Psyche, an asteroid so rich in metal that it boggles the mind. Imagine a giant hunk of iron and nickel, so vast that its worth could dwarf the entire global economy. This is 16 Psyche, a celestial body that has captivated scientists and dreamers alike. The possibility of mining asteroids like Psyche has sparked our collective imagination. It holds the promise of untold riches and a potential solution to Earth's dwindling resources. But the journey to unlock Psyche's secrets is fraught with challenges. It will require cutting-edge technology, international cooperation, and a deep understanding of the ethical and environmental implications. The allure of 16 Psyche is more than just its potential monetary value. It represents a scientific enigma, a glimpse into the early solar system's formation. By studying Psyche, we can unlock clues about the birth of planets and the processes that shaped our cosmic neighborhood. In the vast expanse between Mars and Jupiter lies the asteroid belt, a chaotic dance of rocky remnants from the solar system's formation. Among these celestial bodies, 16 Psyche stands out, a metallic anomaly in a sea of stone and ice. Discovered in 1852 by Italian astronomer Annibale de Gasperi, Psyche was named after the Greek goddess of the soul. What sets Psyche apart is its composition. Unlike most asteroids, which are primarily composed of rock and ice, Psyche is believed to be made almost entirely of iron and nickel. Radar observations and measurements of its gravity suggest a porous structure, indicating that Psyche might be the exposed core of an early protoplanet. Stripped of its outer layers by colossal impacts billions of years ago, Psyche's size is also impressive. With a diameter of approximately 140 miles, it's one of the largest objects in the asteroid belt. Its sheer mass and metallic composition mean that Psyche harbors an unimaginable amount of valuable resources. Estimates suggest that the iron alone in Psyche could be worth more than $10,000 quadrillion, a figure that dwarfs the entire global economy. The allure of 16 Psyche has spurred NASA to embark on an ambitious mission to study this metallic world up close. The Psyche spacecraft, named after its target, is scheduled to launch in October 2023. This mission marks humanity's first-ever visit to a metal-rich asteroid, promising to revolutionize our understanding of planetary formation and the early solar system. The Psyche mission has several key objectives. The first is to determine whether Psyche is indeed the core of a protoplanet, offering a unique window into the internal structure of celestial bodies. By studying Psyche's composition, scientists hope to gain insights into the processes that led to the differentiation of planets into their distinct layers, like Earth's core, mantle, and crust. The mission will also investigate the age and formation history of Psyche, searching for clues about the violent collisions that shaped the early solar system. Understanding these ancient events can help us piece together the history of our own planet and the conditions that led to the emergence of life. Section 4. The Journey to a Metal World. The Psyche spacecraft's journey to its metallic target will be a long and arduous one. After its launch, the spacecraft will embark on a 6-year journey to reach 16 Psyche, utilizing solar electric propulsion to navigate the vast distances of space. Upon arrival in August 2029, the spacecraft will spend 26 months orbiting the asteroid, gradually decreasing its altitude to get a closer look at the surface. During its mission, the spacecraft will employ a suite of sophisticated instruments to study Psyche in detail. A magnetometer will measure the asteroid's magnetic field, providing insights into its internal structure and composition. A multispectral imager will capture high-resolution images of the surface, revealing its geological features and any potential signs of past impacts. A gamma-ray and neutron spectrometer will analyze the composition of Psyche's surface, providing detailed information about the abundance of different elements. These measurements will be crucial for determining whether Psyche is indeed primarily composed of iron and nickel, and understanding the distribution of other elements within the asteroid. Section 5. The Challenges of Space Mining, a Technological Tightrope Walk. While the prospect of mining asteroids like Psyche is enticing, the reality of space mining is fraught with challenges. Operating in the harsh and unforgiving environment of space requires overcoming numerous technological hurdles and developing innovative solutions. One of the primary challenges is the development of robust and reliable spacecraft capable of withstanding the rigors of deep space travel. These spacecraft need to be highly autonomous, capable of navigating vast distances, making complex decisions, and operating with minimal human intervention. Another hurdle is the development of efficient and cost-effective methods for extracting resources from asteroids. Traditional mining techniques are not feasible in space due to the lack of gravity and atmosphere. New technologies, such as robotic mining, laser ablation, and solar thermal extraction are being explored to overcome these challenges. The transportation of mined resources back to Earth presents another significant hurdle. The sheer distance between Earth and the asteroid belt makes transporting large quantities of material extremely costly and time-consuming. Section 6. Space mining's economic impact, boom or bust. The potential economic impacts of space mining are vast and complex. On the one hand, the abundance of resources in space could revolutionize industries, drive technological innovation, and create new economic opportunities. The availability of vast quantities of metals like iron, nickel, platinum, and gold could disrupt global markets, potentially leading to price fluctuations and economic instability. The influx of these resources could benefit certain industries while negatively impacting others. The ethical implications of resource use and distribution also need careful consideration. Should the resources of space be considered a common heritage of humanity, or should private companies be allowed to claim ownership and profit from their extraction? The potential for economic gain from space mining is undeniable. However, it's crucial to approach this new frontier with a balanced perspective, considering both the potential benefits and risks. Section 7. The environmental conundrum of cosmic quarries. While space mining is often touted as a solution to Earth's dwindling resources, it's important to consider the potential environmental implications of extracting resources from celestial bodies. The process of mining asteroids could generate space debris, posing a hazard to spacecraft and potentially even Earth. The extraction and processing of resources could release dust and gases into space, potentially altering the albedo of celestial bodies and affecting their temperature. The transportation of resources back to Earth could also have environmental consequences, particularly if it requires the use of energy-intensive propulsion systems. The potential for accidents during launch, transit, or atmospheric re-entry could result in the release of hazardous materials. As we venture into the realm of space mining, it's crucial to prioritize sustainable practices that minimize the environmental impact on both Earth and the celestial bodies we seek to utilize.